So good morning students. This is a class of geotechnical engineering. So I guess we are discussing about in the previous class that we are discussing about consistency of soil. So some a few parameters are still to discuss. So let's go back to that consistency of soil. Okay. So let me share my screen first. So my screen is visible, right? So I guess we discussed about consistency limit, that is liquid, plastic, and shrinkage limit in the last class. Okay. So also discuss about how to I think yeah, you will get the procedure of to determination of liquid limit in your student portal. You can go through your student portal in the laboratory section. You will get some detailed procedure and a video link for the guidance how to do or how to determine liquid limit in laboratory. Okay, so liquid limit can be determined by two different methods are there. So one is discussed in the this already discussed in the ERP. Okay, so we'll just go through this. It is called Casagrande method to determine liquid limit of soil. Okay, another method is also there, cone penetration test for determination of liquid limit. You can also go through your textbook to find out how to determine the liquid limit. Okay, plastic limit we also discussed in the last class about plastic limit. We also discuss about how to determine plastic limit in laboratory. You can also go through your student portal for the reference. Okay, we also discuss about shrinkage. Yeah, did we discuss about shrinkage limit in the last class? Because I have little doubt whether we have discussed shrinkage limit or not. Please, anyone, please do respond. Did we discuss about shrinkage limit or not in the last class? If yes, then I'll just proceed to the next one.
No, sir.
Okay, fine. So yeah, so till now we have discussed about plastic limit and liquid limit. Okay, it is similar to that only but little different, small difference are there. So here the first definition is almost you can say from the diagram that we already discussed in diagram. So what is shrinkage limits? It is the boundary limit, isn't it? Shrinkage limit also represents the boundary limit, the water content between the solid and semi-solid state of consistency of soil. It is very simple definition come from this diagram. Okay, that is what diagram. There is a variation of volume with water content. Okay, now let's go back to the again to the definition. Yeah, so here it is written. It is the maximum. X second. X second. Yeah. So it is the shrinkage limit is defined as the maximum water content at which soil behaves as a solid material. Okay, what is this? We'll discuss later on. Okay, first of all, let's see the next word definition. It is the maximum water content below which decrease in water content results in no change in volume of soil. Now it's very important definition. Third one is what? In other words, it is the arbitrary water content between solid and semi-solid phase of soil. So yeah, it is a very simple definition. I will start from the third one. Okay, so what is this? Shrinkage limit is defined as the arbitrary water content between solid and semi-solid phase of soil. It is a very simple um, definition, general definition. So from the even from the diagram, you will get the idea. So it is the arbitrary limit of water content between solid and semi-solid state of consistency of soil. Fine. Now from the second definition, what is called? It is the yeah, it is the maximum water content below which decrease in water content result in no change of volume of soil. So why it is say like that? So from the diagram also even you can see now you can see that this curve is decreasing linearly from liquid, plastic and shrinkage point. Then even after just after a reduction, a small amount of reduction of water content beyond this level to the left side, okay, you can see the curve goes parallel to the horizontal. That means it becomes horizontal to the x-axis. Means what? At every point, suppose this water content is suppose 50%. Okay. Now if I go decreasing in this direction, say 40, 30, 20, 10, 0 like that. Okay. So suppose at 50% water content, the volume of soil say at 20 centimeter cube. Okay, for example. Okay. Now, if I again reduce some water content from the soil, say up to 40, even at 40% water content, soil have the same volume. That is 20 cc. That is 20 centimeter cube. You try to go decreasing in water content up to zero, but there will be no change in volume. You can see the horizontal line is coming up to this level. Okay. So why it is this? That means why the volume is not changing. Okay. That means in this scenario, the soil is this count as solid stage. Okay. Now, if I start from this point, okay, we'll just go in a reverse direction now. Now, suppose you have taken a fully dry soil. So, what do you mean by dry soil? A dry soil contain soil solid and voids containing air only, isn't it? So there will be no place of water. Fine. Suppose you can also imagine one three-phase diagram of soil. Okay, say three-phase, yeah, two-phase diagram of soil. Okay, suppose for a dry soil, it will be a two-phase diagram. That means at below soil solid, at above voids which contain air for a time when the soil is dry. Fine. Now, um, if I allow water to enter in the soil, what will happen? It will become partially saturated soil. Okay. Suppose in a dry soil, I added some amount of water. Okay, some amount of water. Then that water will goes to where? The water will take a place in the voids which were taken by the air previously. Okay, but it doesn't mean the volume will change. Volume will remain same. Volume of voids remain same. Only what will happen? The places, the voids that taken by air previously, now it is taken by the water that I have added in the particular soil. Fine. So in that case, the soil becomes what? In a three-phase state. That means it may contain soil solid, water, and air. Okay. So suppose I added from suppose this point is called 0 point. Water can add 0%. That means the soil is dry. And initially, when there is no water, the soil have this much of volume. You can say any number. Okay. Now if I add some amount of water, suppose here up to this point, even the soil now in this case the soil is in two-phase diagram, a two-phase state. Now when I add some amount of water, it now convert to three-phase state. That means three-phase component it has. That means soil solid, water and air, but there will be no change in volume. Now you can see that there is no change in volume. The constant is going up to this point. Okay, now if I try to increase the water again and again and again, okay, so up to this point, that means up to the shrinkage limit, this point, the volume of the soil will not change, and this will happen only we are talking about only fine grained soil. Okay, fine. So up to this point there will no change in volume. That means up to this point, that means at a shrinkage limit, at this point the soil become fully saturated. Okay, and before this the soil is partially saturated. Okay, and this line at this point is soil is in dry state. Okay, now we added water, then this whole at this point the soil becomes partially saturated, and at this point the soil become fully saturated. Now what do you mean by fully saturated? Soil uh, contain two component only, that means soil solid and water, that is the voids are filled with water only. Okay, now if I try to again increase some water in a particular soil, then what will happen? We are talking about fine grained soil. Okay, so fine grained soil have a capability to increase its volume. Okay, because they have a ability to hold water. Okay, because they can attract water component at that hydrogen ion, hydroxyl ion. Okay, by the minerals present in a particular fine grained soil. Okay, so we'll not go in so much detail, okay, for now, but you just concentrate here. The fine grained soil have a capability, especially clay soil have a capability to hold water. Okay, and for holding more water, they can expand their volume by expanding their volume of void actually. Okay, the volume of voids can be expanded. So up beyond this point, if you still increasing the water content, that means after shrinkage limit, if you still increasing the water content, what will happen? To hold that certain extra water, the volume will go and increasing. Okay, for a particular soil. Again, if you increase again water, it will again increase. So like that, with increase in water content, volume of the particular fine grained soil goes on increasing in this direction. Okay, and different zones are divided or particular soil since they reach different state. From if I start from left to right, it's called dry, sorry, solid state, then semi-solid, then plastic, then liquid. Okay, so you can also reverse in direction or in this direction. Anyway, fine. So what is shrinkage limit? By the second definition, it is the maximum water content. Wait, it is the maximum water content below which decrease in water content result in no change in volume of soil. I think this is now no can be understandable, isn't it? So if you still decrease the volume, if you still decrease the water content, volume will not change. Okay, so it is this point is known as shrinkage limit. Fine. Yeah, so it is a maximum water content at which soil behaves like a solid material. So it is all actually related to the third definition. So since uh, yeah, up to this point, till this shrinkage limit point is not reached, this whole at this region, this known as solid state. That means at every water content, the soil will be in solid state. Simple as that. Okay. So this is all about liquid limit, plastic limit, and shrinkage limit. So any doubt till now? समझ में आ रहा है कि नहीं?
Yes, sir.
Okay. So yeah, it is known as Atterberg limit also. Okay. So yeah. So some significance of consistency limits are given here. You can also go through this. I'll just want to go through the reading. Okay. So just listen. The consistency limit. When I say consistency limit, it covers all three. That is shrinkage limit, liquid limit, and plastic limit. All three. Okay. So consistency limits are very significant in the study of clay and other fine grained soil. So we have already discussed that it is the property of fine grained soil only, especially for clay soil. The liquid limit. I'll do. Okay. So the liquid limit and um, plasticity index are extremely useful for a classification of soil. So plasticity index is not mentioned here. So I'll just go plasticity index not represent here. Let me give first before discussing this. I just want to give you some information about that plasticity limit. Okay, just hold on. Wait. Yeah. So before going in detail, so there is some parameter that we need to discuss about. All are related to that consistency index. Okay. So here, so we discussed till now that about shrinkage limit. Now we will discuss some about some consistency indices. Okay. So there are some consistency indices. Such few important parameter. Okay. Nothing in-depth concept here. So yeah, first one is plasticity index. So it is a parameter. It is defined as IP, capital I, capital P, IP. Okay, or also it is denoted by this symbol. Here you can see capital I suffix P. Okay, IP. So plasticity index. How to determine plasticity index? If you know for a particular fine grained soil, if you know liquid limit and plastic limit, the difference between liquid limit and plastic limit is known as plasticity index. Okay, that is WL minus WP is known as plasticity index. Okay, so some important terms are given here, like it is the range of the water content in soil during which the soil behaves as a plastic material. Okay, and simply it is the difference between the water content at liquid limit and plastic limit. Okay, and highly plastic soil exhibit greater plasticity value. That means uh, greater the value or plasticity index, you can say the soil is highly plastic, like that. So here's some tabular format for defining a particular fine grained soil, whether it is plastic or non-plastic, whether low plastic, high plastic. So there is a range. So you just try to remember this. So here is a range of plasticity index and soil description. That means if the liquid limit minus plastic limit becomes zero, that means there is no plasticity in the soil. Okay, that means the soil is in liquid state, we can say. Okay, like that. So we will just go through this. Next, shrinkage limit is also there. Same way, shrinkage limit, it is defined as a difference between plastic limit and shrinkage limit. Okay, the difference in the water content at plastic limit and shrinkage limit. So it is also defined as the range of water content at which the soil behaves as a semi-solid material. So from the diagram only, you can understand. Okay, it's very simple, small definition. Before that, yeah, flow index. So this one can be understand by from the liquid limit determination by Casagrande method. Okay, so to understand flow index, you just go through your student portal um, in that determination of liquid limit of soil. Okay, so from the liquid limit determination by Casagrande method, you have to plot one graph. Okay, the graph between numbers of flow versus water content. Okay, and the slope of the curve is known as flow index. Okay, so it will not hard to understand. You just go through the video link that given in your student portal for determination of liquid limit by Casagrande method. It's also known as Casagrande method for determination of liquid limit. There you will find out this flow index value. Okay, so it is denoted by this formula. Okay, so you will not understand now, even only after the um, after understanding the procedure, you will get this idea. Okay, next, consistency index are in some exam, these formulas are frequently asked. Okay, this the consistency index, liquidity index, this actually asks. Okay, so you just try to remember this formula. So what is consistency index? Denoted by capital I suffix C. Consistency index is defined as a ratio. You can see WL minus WN, that is natural water content. WN means the natural water content. It means the natural water content that is found or determined from the soil, which is directly taken from the field. Okay, it is called natural water content. So for a particular soil, we can find out liquid limit and plastic limit also. Okay, after finding plastic limit and liquid limit, you can find out plasticity index, that is IP. It is also defined as WL minus WP, that is liquid limit minus plastic limit. So it is a relation. Consistency index is defined as a ratio between the liquid limit and natural water content of soil to the plasticity index. So here is the um, mathematical representation. So you just try to remember. Okay. So you also try to remember this tabular format. Okay. Some conditions are there, whether soil is in liquid state or plastic state. You will get this idea about. Okay. Then liquidity index. So it is almost similar. You can say. So here small difference are there. So liquid limit what? It is denoted by, sorry, liquidity index. It is what? IL, denoted by IL, and it is what? It is a ratio of what? Difference between the natural water content and the plastic limit to the plasticity index. Now can you see the difference? Okay, don't mix with these two. Okay, it's very important to understand and try to remember this formula. In some exam, frequently ask this. Okay. Yeah, some others are there. Toughness index, yeah, this one also very important. So try to remember this one also, toughness index. So it is the ratio of what? Plasticity index to flow index. So plasticity index is already defined to you, liquid limit minus plastic limit. Now what is flow index? Flow index also we already discussed, right? Here from the liquid limit test you will find out the flow index. Okay, try to learn about how to determine liquid limit of soil by custom method in laboratory. It will be available. It is available in your in student portal. Okay, fine. These are some important parameters. One important parameter also left here, the density index. Okay, so density index, it is not directly related to your consistency index of soil. Okay, but it is here only. So what is density index? Density index can be sometimes it is also known as sometimes. Um, let me check. Okay, hold on. Let me check another name. Uh, yeah. So density index can be known as relative density or degree of density. Okay. So here it is the formula for representation of density index. Okay. So how to state the definition? So it is the ratio. You can see it is the ratio of difference between the void ratio of cohesionless soil in the loosest state and void ratio in its natural state to the difference between the void ratio in the loosest and densest state. So it's look like very long definition, but if you remember this formula, the definition is become very easy. Now ID, capital I, small suffix capital D. So ID represents what? Relative density or density index. Okay. So it is the different. It is the ratio of what? Small e. Small e represents what? Void ratio. Okay. So it is a ratio of void ratio only. So now you can see E max minus E natural. Here what? E max minus E minimum. Multiply by 100 since it is represented in percentage. Okay. Now E
Sir.
max what? It is the maximum
Hello.
void ratio. E minimum is what?
Hello,
It's
sir.
the minimum void ratio. Okay. Fine. And E natural what? Is your natural void ratio. That is come from the natural soil. Okay.
Hello, sir.
Yep.
Sir, can you show me the liquidity index?
What? Liquidity index.
Yes, sir.
Okay. Can you see here?
Okay, sir. Sir, we
So you
can
just try to
calculate
remember
it
the
in
formula.
a
Okay.
percentage,
Liquidity
right?
index is defined as a ratio of what? Natural water content minus
Sir,
plastic limit.
the
Plus
value will become in a percentage, right?
which one?
Liquidity index.
Index are all in number. Okay. Fine.
Sir, in
You can
formula,
also
we
come
have
in
to
percentage.
multiply
You
by
can also
100%, right? Sir?
see. You can also find out in percentage or in number. Okay.
Okay,
So
sir.
there is no hard and fast rule there. Okay. So you can see if I see go for mathematically. So yeah, you can also write down in percentage.
Sir, without percentage also we can calculate, right?
Yeah.
Or, I mean, the number will become right.
Yeah.
The answer will be same, sir.
Yeah, same.
Okay, sir. Thank you.
Okay. Yeah. So yeah, what we discussed, yeah, density index, right? So density index is defined as, now go through the definition and just try to concentrate on this formula. Now see, it is the ratio. Now you can see it is the ratio of difference between the void ratio. Now you can see that it is the difference between the void ratio, of cohesionless soil in the loosest state. Now what is the void ratio in loosest state? When a soil is in very loose state, the void ratio will be maximum. Since in the loose state, the soil particles are too far from each other, the voids will be more. Okay, so in case of loose state, void ratio will be higher, that is E maximum. I can repeat, it is the ratio between the void ratio of cohesionless soil in its loosest state and void ratio in the natural state to the difference between the void ratio in the loose state and dense state. Now dense state means what? A soil is dense state means the soil particles are so close to each other. If soil particles are so close to each other, that means there will be very less voids. Okay, the voids will be very minimum. That means that's why it is denoted by E minimum. Okay, so from the definition also you can also remember this formula, or even from the formula you can remember this definition. It's up to you. Okay, okay. So yeah, some miscellaneous properties are there. These properties are mainly related to your clay soil. Okay, these two property. So I just want to read it out. Sensitivity and activity. Okay, so what is sensitivity? It is defined as the ratio of unconfined compressive strength of an undisturbed soil sample to the unconfined compressive strength of the same soil after remolding at unaltered water content. So I don't think you will already you have got this compressive strength. Okay, shear strength. I think you will not. You haven't got this, right? So Chinu ma'am is will be discussing with you about shear strength of soil. Then you can find out this. Okay. So till now try to remember this formula. Okay. Till now try to remember this formula. That means it is a compressive strength, unconfined compressive strength of. एक सेकंड ना. हेलो. हेलो बोलो जल्दी बोलो, मैं क्लास में हूँ. हाँ बोलो. तुम एक काम तुम्हारा लोकियो मेला क्या क्या है, तुम्हारा सब्जेक्ट क्या है अभी? हाँ, मुझे मुझे मैसेज करो, मैसेज करो. हाँ हाँ यहाँ पे. Okay. So yeah, I just try to remember for now. No, I will not go in detail about unconfined compressive strength for now because it's contained a huge chapter. Okay. So for now, just try to just remember this sensitivity. It is a property of clay soil. Similarly, activity, it is also a property of clay soil only. Okay, so it is a ratio how to find out activity of particular soil. It represents what? IP divided by how much percentage of clay particles are present in a particular soil. The ratio of IP by percentage of percentage of clay soil, that is smaller than 2 micron. Okay. So yeah, this is all about for today class. Okay. So yeah, we already discussed about consistency of soil, that is also known as Atterberg limit or consistency limit, and some other parameters that are related to your consistency of soil, that is plasticity index, shrinkage index, then
Sir,
flow index,
hello.
and consistency index, liquidity index, toughness index, density index. All these things are important from your exam point of view. Okay, in some exam they may ask about this. Okay, basically the formula. Yeah, anyone?
Sir, can you explain activities?
Activity. See,
Yes, sir.
activity is actually represents what? See, clay soil have a ability. Okay, a clay soil have ability to expand its volume. Okay, clay soil have ability of consistency limit. That is liquid limit, plastic limit, shrink limits. Okay, plasticity. They all are properties of mainly exhibit in clay soil. First thing you have to understand this. Okay, clay soil are like a soil that can change their volume based on the water content. Okay, that means we can already discuss about this, right? This diagram. So a clay soil can increase its volume with increase in water content. Fine. So in your soil, whatever soil you have for now for taste, whether it is soil is active or not, that means it can change the volume or not, whether it have the plasticity or not. Okay, so to understand that, a new term is introduced here, activity. Okay, activity means it represents how much percentage of clay is there in your soil. Fine. So from the research it's got, the activity can be defined as the ratio of plasticity, sorry, what plasticity index, what is called plasticity index is called, right? IP. Let me check. Yeah, plasticity index, that is IP, divided by the percent of soil. Okay, from the same analysis you will get how much percentage of soil are there finer than 2 micron, isn't it? It is 0.002 millimeter. It is the size for clay soil. The percentage of soil finer than 2 micron, this represents what? Clay soil. That means IP divided by the weight of the soil, which I weight of clay soil, it gives you activity. Simple is that. Now from the value of activity, you will find out whether the soil is active or not, whether inactive or normal soil or active soil. So from this data, that means if the activity value is smaller than 0.0 or 0.75, we can say it is inactive soil. If it is more than 1.25, you can say the soil is active soil. Okay, they may have some certain property of clay. That means, okay. Now it's intermediate one. That means it's a normal soil. It may show, but in a small range or small amount of I know property of clay will be showing. Okay. So yeah, anything else to discuss here till now? Both all are very small things. You can also Google it, or you can just cross check in your textbooks. Okay. So anything else to ask? If not, then I'll just close my recording. Okay.